Welcome to part 2 of the December assessment revision video. Here we're going to be looking at some calculated topics. Again, I suggest that you pause the video before the questions, attempt the questions, then press play to see if you got the answer correct. Here we've got distance, speed, time. We're told that speed is equal to 30 miles per hour, distance is equal to 200 miles. First thing I'm going to do is I'm just going to draw out my distance, speed, time formula, which states that distance is equal to speed multiplied by time. So distance is equal to speed multiplied by time. Now what we're given here is the distance and the speed, so that means that we're going to be doing the distance 200 divided by the speed 30. Now this is going to give me an answer, and I've got a calculator here so I may as well use it. 200 divided by 30, and it gives me an answer of 6.6 recurring hours. Now that seems quite a strange answer here, 6.6 recurring hours, and we wouldn't usually say this in real life, so we try to avoid writing it as our answer in assessments and exams. So ideally we want to give our time in hours and minutes. Now in order to do that, well, what I can do is I can turn 6.6 hours into minutes simply by multiplying by the number of minutes in an hour. So 6.6 recurring hours multiplied by 60 minutes, that gives us 400 minutes. So there are 400 minutes. These two things are exactly the same. So then all I can do then is say, well, okay, I've got 400 minutes. Well, how many 60s are there in 400? We already know that's 6, and that would be 360 minutes. So I've got 6 hours is my 360 minutes, then I've got an extra 40 minutes on top of that to get up to 400 minutes. So my time here would be 6 hours and 40 minutes. Now here I've got again I've got time, speed, looking for distances on this occasion. So I'm going to do speed multiplied by time, 20 multiplied by, now I've got a problem, 3 hours 30 minutes. Ideally I want to have this as a decimal, so what I can do is essentially the reverse process of what we did here. Let's turn this 3 hours and 30 minutes into a decimal. So what we did last time was we took our decimal, multiplied it by 60, then went from there. Well, what I can do here is I've got 3 hours and 30 minutes. That's the same as having 210 minutes. And then so to get to my decimal, well, to get from my decimal to minutes, I times by 60. To do the opposite direction, divide by 60. So that gives me 3.5 hours. So I'm going to do 20 multiplied by 3.5 hours, and that's going to give me an answer of 70 miles. I know it's 70 miles because I've got miles per hour here. So my final answer is going to be 70 miles. Okay, next topic, value for money. Sugar is sold in 2 different sized packets. Small packet is 450 grams and costs £1.20. A large packet is 1 kilogram and costs £2.50. Which packet is the best value for money? So the first thing I'm going to do here is I'm going to think, well, okay, let's work out how much 1 gram would cost me with the small packet. So just label it the small packet. Here 1 gram is going to simply cost me, well, let's first off call this, instead of having it £1.20, let's say that this is equivalent to 120p. So let's work in pence, it's just a bit simpler for the numbers that we've got. So I've got 1 gram, and for the small packet I've got 450 grams. So what I can do is I can simply say, well, let's take the amount of money, 120p, and divide it by the number of grams that I've got in my packet. That would tell me what 1 gram is going to cost me. So 120p divided by 450, that's going to give us an answer of, so 120 divided by 450, that's going to give us 0.26 recurring, and that is pence. So 1 gram is costing me 0.26p. So let's do the same with the large. And so 1 gram. This time my amount of money is 250p. And I've got 1 kilogram. Well, 1 kilogram is the same as 1,000 grams, so divide by 1,000, and that's going to give me 0.25p. So what I can say then is that with the large packet, 1 gram is costing me 0.25p. For the small packet, 1 gram is costing me 0.26 recurring pence. So what I can say then is that the large pack offers me better value for money. I am paying a smaller amount of money for the same number of grams. So large packet is better value for money. I'm just going to abbreviate value for money to VFM just to save me writing. So when we are in an assessment, the best thing to do here is to label this out nice and clearly by making a comparison of two amounts and then write a statement at the end saying which is the better value for money. Now this is one way of doing it. We could also think about it in another way. We could also think about it as how much sugar am I getting for 1 pence, say. So how much sugar am I getting for a certain amount of money, and making a comparison that way. So let's think about it like this. Well, how much sugar am I getting when I'm paying for 1 pence with the small packet? Well, I'm getting 450 grams of sugar, and I'm dividing that by the total number of pence, which is 120. So doing this, 450 divided by 120, I can say that that is 3.75 grams. So 1 pence, for 1 pence with the small packet, I'm getting 3.75 grams. For every 1p that I'm paying, that's equivalent to me getting 3.75 grams of sugar. Let's do the same with the large packet, and I can say that 1p here is going to be the total number of sugar, which is 1,000 grams, divided by the amount of money that I'm paying for it, 250p. So for every 1p that I spend on sugar here, I'm getting 4 grams of sugar. Sorry, for every 1p that I spend, I'm getting 4 grams of sugar. So now I can see, well, okay, which packet is the better value for money? Well, I'm paying 1 pence and getting 3.75 grams for that 1 penny that I'm spending with the small pack. When I'm spending 1 penny with the larger packet, that gets me 4 grams of sugar. So again, I come to the same conclusion. The larger pack is better value for money. Either of these methods are fine, as long as you make a comparison between the two packets using a comparative amount, i.e. working out what 1p is getting you in terms of sugar, or working out how much 1 gram of sugar is costing you. As long as you make a comparison between those two and then make a statement at the end, you'll get full marks. Okay, next topic, density. Here we need to remember our formula, which is that mass is equal to the density multiplied by the volume. So what I can say here then is that I've got the volume and the density. I'm simply going to do 200 volume multiplied by the density, which is 30, and that's going to give me an answer of 6,000. Now what is my unit here? I'm dealing with mass. It's 30 grams for every centimetre cubed. I've multiplied that by 200 centimetres cubed, so it's going to be 6,000 grams. I could also say that that is 6 kilograms. So say for example, if I was looking for volume, then I would do mass divided by density. If I was looking for density, I'd do mass divided by volume. We looked at this the other day, so we should be fairly comfortable with this. So on we go. Next one, find the circumference and area of the circle. So first of all, I'm just going to state this length that I've got here. What is this length that I've been given? I can see that this is the distance from the circumference to the centre of my circle. So I could say here then that the radius is equal to 6, and that's 6 centimetres. I could also say, you don't have to write this down, but it's useful when we're using our formulas in a minute. I could also say that the diameter is going to be 12 centimetres. The diameter just being a line from the distance from one side of the circle through the middle to the other. And we can see that that would just be twice the radius. So let's work out our circumference first. So the formula for circumference is pi multiplied by the diameter. So the circumference is pi d. Now I've already worked out that the diameter is 12, so it's simply going to be pi multiplied by 12, and that's going to give me my answer. So let's work that out. Pi multiplied by 12, that's 11. Pi multiplied by 12, that's going to give me 37.7. It hasn't told us to give any degree of accuracy, so we'll just go to one decimal place. We'll say that is 37.7 centimetres. So remember that the circumference is simply the distance around the edge, and so the circumference here is 37.7, and that's centimetres because we're just simply measuring a length, we're measuring a distance. Now for the area, our formula is pi r squared. So area is pi times the radius squared. Here our radius is 6, so we're going to do pi multiplied by 6 squared. Typing this into our calculator, pi times 6 squared, that's going to give us 113, and again we'll go to one decimal place, so 113.1 is going to be our answer here, 113.1, and then we're dealing with area this time, so it's going to be centimetres squared. Okay, next one, find the area of the following shapes. So here we've got a right angled triangle with a height of 7 and a base of 4. Our formula here is the base multiplied by the height divided by 2. So our base here is 4, our height is 7, and we need to half it. 4 times 7 is 28, divided by 2 gives us 14, and that is, dealing with area, centimetres squared. This part 1 here, we've got a parallelogram. To work out the area of our parallelogram, we simply do the base multiplied by the height, so ignoring this length on the side, so we're going to do 6 multiplied by 8, and that's going to give us an answer of 48, and that's centimetres squared. Next one, we've got a trapezium. So for our trapezium, we add the two parallel sides together, so 6 plus 4. Then we multiply that by the height, which is 5, and then we half it, so we divide it by 2. So we're doing 6 times 4, which is 10, times by 5, that's going to give us 50, divided by 2, that's going to give us 25, and that is centimetres squared. Okay, next one, calculate the volume of the prism. To work this one out, we simply find out the area of the face that runs through the prism, in this case it's a triangle, and then multiply it by the length. So in this one we're going to do 8 multiplied by 6, base multiplied by the height, like we just talked about a moment ago, divided by 2. That's going to give me the area of the face that runs through the shape, and I'm simply going to multiply that by 60. So working out the area first, I'm going to do 8 times 6 divided by 8 times 6 divided by 2, then multiplying it by the length of the prism, so times by 60, and that's going to give me 1,440. So 1,440 0. We're dealing with a volume, so that's going to be centimetres cubed. Okay, next one, calculate the surface area of the cylinder. So surface area, in order to find this out, all that we're talking about with surface area is simply the area of each of the faces. So in a cylinder we've got a circle at the top, and we've got a circle at the bottom, and then we've got a rectangle going around our shape. So let's work out the area for each of these. Well, each of the circles has got a diameter of 6 centimetres. So to work out the area here, I need to do pi times the radius squared. So the area for this shape is going to be pi times the radius, which is 3 squared. I've got 2 of those, so I'll do exactly the same calculation again. And then for this last part, I've got a height of this rectangle is 8 centimetres, I can see that there. Then this part here, well, that is simply the bit that wraps itself around the top. So that distance is simply going to be the same as the circumference of the circle that is on top. So that's going to be pi multiplied by the diameter, which is 6, so pi times 6. So the area for this rectangle is going to be pi multiplied by 6 multiplied by 8. So working out what each of these are, we're asked to find the surface area. Well, the surface area just means adding up the areas for each of the faces, and that will give us a surface area. So I've got pi times 3 squared, that's given me the area of that circle there. Then I've got 2 of those, so let's just double that. And then lastly, I just need to work out the area of this rectangle, so add on, and then I need to do pi times 6, so that part there, multiplied by the height, which is 8. Then that's going to give me a final answer of, notice that I added each of these up as we went along, left everything in my calculator. That's the best way to do it, to avoid making any errors with that accuracy. This gives an answer of 207.3 to 1 decimal place. So 207.3, we're dealing with surface area, so that is centimetres squared. Okay, last one. Find the area of the sector and find the length of the arc. So the area of the sector is simply the amount of area that is in this sector here, so the amount of space inside this shape. The length of the arc length is simply the distance of the curved part of our sector, so that bit around the edge. Well, what we need to remember here is our formulas for the circumference and the area of circles. So for the area of a circle, we talked about it earlier, the area of a circle is going to be pi times the radius squared. The circumference of a circle, the circumference is simply pi times the diameter, pi d. So, working out first of all the area of the sector. Well, that's simply going to be, so the area for the whole circle would be pi times 12 squared. So pi times the radius squared, given our radius here. Now we've only got 150 degrees out of 360 in total. So I'm just going to multiply 150 over 360 by what the area of the circle would be in total. So typing this into my calculator, I'm going to have 150 divided by 360, then multiplied by pi multiplied by 12 squared. So that's going to give me 188.5 centimetres squared to 1 decimal place. So 188.5 centimetres squared. Now the length of the arc, the distance of this curved part here, that's simply going to be the same idea, but instead using the circumference. So the circumference of the entire circle, if we had the entire circle that this arc that this sector has been taken from, if I had that entire thing, the circumference would be pi multiplied by the diameter. Now I've been given the radius of this here, so I need the diameter, which would be double the radius, 24. Then what I've got is I've got 150 degrees out of 360, so take that fraction and multiply it by the circumference, and so that's going to give me 150 divided by 360 multiplied by pi multiplied by 24, and that's going to give me an answer of 31.4, and on this one it's simply centimetres because we're measuring that distance.